Welcome back to Roaring Springs Water Park. The park is about to open, and I'm planning the most efficient path so I can be the first one on a slide this morning. Here's the map of the water park. See how the parking lot and the ticket booth are on this same straight path? Is Slide Central on that same path so we can go straight there when we enter the park? To figure this out, we need to use slope triangles. So, like I was saying, we're focused right now on these parts of the map: the parking lot, the ticket booth, and Slide Central. Since I want to be the first one on the slides, I need to be efficient and fast. It's best if I can go straight there without making any turns. So let's see. We have the path between the parking lot and ticket booth on the map as this straight line. Will that line extend to Slide Central? How can what we know about slope and slope triangles help us figure this out? Well, we know that slope is the steepness of a straight line. In this case, the map is showing a view from top down, like a bird's eye view. So we aren't seeing how hilly these paths are, but instead whether they are pointing to the northeast, southwest, etc. Points on the same line have the same slope connecting them. So, if we can figure out the slope of the first 2 points, that will help us determine whether the third point is on the line or not. Well, let's start by figuring out the slope between the parking lot and the ticket booth. Draw a slope triangle. Which way did you draw it? On the right or on the left? Either way is fine, just be sure you know the rise is always the height of the triangle and the run is always the width of the triangle. How many units tall is this triangle? 6 units. That's the rise, which goes on the top of the slope fraction. So we have a 6 as our numerator. What's the run? 2 units. So our slope is 6 over 2. Is that simplified? No, because we can divide both numerator and denominator by 2. That simplifies to 3 over 1. We could continue simplifying that to just 3, but we usually write slope as a fraction. Don't forget to figure out the sign. The line is rising as it goes from left to right, so the slope is positive 3 over 1. Cool. But how does that help me get to Slide Central? Let's see where we end up if we keep on this path. From the ticket booth, we'll use the graph and rise 3 and run 1 to draw the legs of our slope triangle. Now draw the hypotenuse. That's the continuation of the line. That didn't reach Slide Central. Let's draw another one from that point we just made. Rise another 3 and run 1, making sure our triangles are the same. And hey, that gets us to point S, representing Slide Central. Yes! Slide Central is on the same straight line path as the parking lot and ticket booth. So it's true, points on the same line have the same slope connecting them. So if we can figure out the slope of the first 2 points, that will help us determine whether the third point is on the line or not. Let's break down the steps of what we just did to figure out whether a third point is on a line. First, we drew a slope triangle connecting the original 2 points. Then, we calculated the slope. Don't forget to simplify and determine the sign. We went on and drew slope triangles to continue the line. Then, we took a look. If the line and third point touch, it's on the line. If the line and the third point don't touch, it isn't on the line. Let's try those steps one more time. This time I want to see whether the ice cream shop point I is on the same line as the aqua coaster and lazy river. You can see on the map that the Aquacoaster point A and Lazy River point L are connected by a straight line. Use the steps to determine whether point I, the ice cream shop, is on that same line. What did you get for your slope? I drew my slope triangle like this and counted out the rise as 12 and the run as 8. Did you simplify the fraction 12 over 8? It simplifies to 3 over 2, and we'll leave it as an improper fraction, not change it to a mixed number, so we can clearly see the rise and the run. And what about the sign of the slope? Is it positive or negative? Since the line falls as we trace it from left to right, the slope of the line is negative 3 over 2. Next up, we had to determine whether point I was on that same line. So I drew another slope triangle in the same direction as the line is going, using a rise of 3 and run of 2. Not there yet. Let's do another. Oh, we passed point I. Point I is not on the same straight line as points A and L. That means the straight path that connects the Aquacoaster and Lazy River does not connect to the ice cream shop. Okay, here's another wrinkle in things. This time we know 3 points are for sure on the same line. However, we only know one of the coordinates of the last point. How can we figure out the missing coordinate? Let me show you what I mean. Roaring Springs wants to add a souvenir shop. It must be on a line that goes through the first aid station and the wave pool. The souvenir shop will be a point on the line that has an x-coordinate of 9. What is the y-coordinate of the souvenir shop? Quick review before we start. In a coordinate pair, which is x and which is y? That's right, the x value is the first number in the pair, and the y value is the second number. So we know the first part of the point is 9, but we don't know the second value. We'll start by figuring out the slope between point F and point W. You've got this part. Pause and determine the slope now. The rise is 2 and the run is 4, which simplifies to a slope fraction of 1 over 2. Is it positive or negative? Yep, the slope is positive because the line goes up as we trace from left to right. Now we're going to draw slope triangles until we get to an x-coordinate of 9. Let's start drawing. That slope triangle gets us to an x-coordinate of 7, so we need to keep going. Draw another, and we land on the x value of 9. Following the line over to the y-axis, we can determine the y value is 5. The y value for the souvenir shop is 5. What if you tried drawing your slope triangle with the unsimplified slope 2 over 4? Oh, look at that. It lands right at the same point. 9, 5. That's because all these triangles are similar right triangles. And similar right triangles' hypotenuses have the same slope. It's still good practice to always simplify your slope, though. Otherwise, you might miss your point by going past it. Your turn. You try this one from start to finish. Keep an eye out. This one is slightly different because you need to find the x value, not the y value of the third point. A line goes through 1, 3 and 5, 2. A third point on the line has a y value of 4. What is the third point's x value? Remember the steps. Draw a slope triangle, simplify your slope fraction, and determine the sign. Continue the line with slope triangles until you reach the desired point. How did you do? The slope triangle I drew had a rise of 1 and a run of 4. The line goes down from left to right, so the slope is negative 1 over 4. No need to simplify, so I kept drawing triangles, this time heading left because my y value was higher than the ones already drawn. After just one triangle, I reached 4 on the y-axis. At that point, I lined up the point with the x-axis and saw it had an x value of -3. So the third point's x value is -3, making the whole point -3, 4. Okay, they're about to open the water park. Thanks for helping me work with slope today. Don't forget to finish your guided notes, complete the simulation, and start the online practice. And remember, math is everywhere. Keep exploring.
Hey, hey.